Hi everyone. Today I want to talk to you about finding the probability of independent and dependent events. When we use independent and dependent events, we are working with more than one event happening. So when I have two or more simple events, they are called compound events. And again, it just means that I'm doing more than one event. For example, I might be flipping a coin, rolling a number cube, spinning a spinner. There's more than one event happening. Now, when I do that type of probability, I have to look at what is happening. And when the outcome of one event doesn't affect the outcome of the second event, we call those independent events. So, for example, if I am going to flip a coin, and then I'm going to roll a number cube, and then I'm going to spin a spinner, it doesn't matter what comes up on the number cube, it doesn't matter what comes up when I flip the coin, it doesn't matter what comes up when I spin the spinner. They are totally independent of each other. None of them depend on the other one. They're separate. So when I'm trying to find the probability of those two events happening, or three events, I'm going to look at, and again, this is how we write probability, the probability of A and B. Well, to find the probability of A and B when they're independent events, I take the probability of the first event and I multiply it by the probability of the second event. So I toss a coin and then I roll a number cube. So again, don't depend on each other at all. And I want to find the probability of tossing tails and rolling a 5. Well, I know the probability of getting tails is 1 out of 2, 2 outcomes, 1 success. And I know that the probability of rolling a 5 on a number cube is going to be 1 out of 6. Again, I have 6 outcomes, 1 success. So then the probability of rolling tails and a 5 would be 1/2 times 1/6, which will equal 1/12. And that's all there is to independent events. I find the probability of each of those events and I multiply. Now, if you think back to a couple days ago when we did compound events and we set up tree diagrams and just lists, you can actually make a tree diagram or a list and show the 12 outcomes. And then as you see those 12 outcomes, you would see that there's only one way that I can have tails and a 5. Now, the second type of probability we're going to look at is when one of the outcomes is affected by the first event. So when the outcome of one event affects the outcome of the second event, they are called dependent events. And what I mean by that is, and you'll see this most often, they like to use the example of marbles in a bowl. And so you may have, for example, 20 marbles in a bowl. And you have red marbles and blue marbles and green marbles. And you're going to draw marbles from the bowl, but you're not going to replace them. So when you begin to do that, now your second event is dependent on what happens in the first event. First of all, you have fewer marbles, and it's possible that you have fewer of the color you want. So let's look at what I mean by that. Okay, a bag contains 7 blue, 3 green, and 3 red marbles. Agnes is randomly drawing 2 marbles from the bag, one after another. Now, she's not going to replace them. She's going to take out one, and then she's going to take out another. And I want to know what is the probability that the first one will be green and then the second one will be blue. Well, if I count up the number of marbles that are in the bag, 7, 3, and 3, I have 13 marbles. And of those 13 marbles, 3 of them are green. Probability of getting a green marble, that's going to be 3 out of 13. Then I want to see the probability of my next one being a blue. Now, remember, I didn't replace that marble. So now, instead of 13 marbles in my bag, I only have 12. So notice that my outcomes are different. This depends on what happens in that first draw. So I have a blue. Well, now I only have 12 marbles, or I have a green. I took out green. So now I have 12 marbles left in the bag. The 7 blue are still there. So the probability this time that I'm going to get blue is 7 out of 12. So the thing about dependent events is that your denominator is going to change each time you do an event. So now to find the probability of green and then blue, well, probability of green is 3 over 13 times 7 over 12. Still going to multiply, but then kind of notice the difference. This says tails and 5. This says green, then blue. That kind of tells you that this is dependent, and that tells you it's independent. So I'm going to multiply my two numbers together. That's 21 over 156. And then if I simplify that, the probability of my first draw being a green and then my second one being a blue is 7 out of 52. Now, don't forget to do your Google form. Again, we'll look at this a little bit more in detail tomorrow in class. It's multiplying, and probably the most difficult is the dependent, and it's just that you have to remember to keep changing that denominator. And then if you are using, for example, the same color, then you're also going to end up changing the numerator as well. So bring your questions to class tomorrow.